Okay, this is a short video of how to solve quadratics by completing the square. It's a difficult process for many, but the steps are here. I listed all the steps for you. First, you have to use inverse operations to move all the constants together. And here's the quadratic, and the constant, they did a nice thing here where the constant is basically on the right side. So I'm just going to rewrite it: x squared plus 8x equals 33. So all the constants are together. Now label A and B. So from the standard form of a quadratic, it is ax squared plus bx equals c, right? So a is the number that is before the x squared, so that is 1. B is the number that is before the x, so that is 8 in this case. So once you have that, you are ready to move to step 3. Step 3 is to divide the b by 2. And you get 4. Then step 4 is to square that. And you get 16. So we have now step 5 is add that result to, I'm jumping ahead here, add that result to both sides of the quadratic. So we have x squared plus 8x plus 16, 33 plus 16. So I'm just going to rewrite the quadratic again. 8x plus 8x, I'm sorry, x squared plus 8x plus 16 equals 49. Now, do you see that step 6 is to factor the trinomial into two binomials. You see the trinomial on the left side right here. So we're going to factor that into two binomials. And that whole thing is going to be equal to 49. So obviously x squared is x times x. And right here, this number, so I don't want you to get confused. That number, the result when you divide b and 2, will always be the factor that goes into here. So it's plus 4 and plus 4. It'll always be that. So you don't have to really search for it. But if you really want to make sense of it, you could do 4 times 4, which is 16, and 4 plus 4, which is 8. And this is pretty easy. Now, the step 7 is to square, put that into square the two binomials. The two binomials, is they're always going to be the same, so it's x plus 4 squared equals 49. And this one is looking really nice because now you have to solve. Step 8 is to solve for x. So we're just going to square root both sides using inverse operations. This cancels, this cancels. Then you have x plus 4. I don't know what I just wrote. So it's x plus 4 equals plus or minus 7. Right? When you take the square root of a number, you have a positive root and a negative root. So we're going to have minus 4 on both sides. We're going to solve for x. And in this case, we are going to have x equals negative 4 plus or minus 7. And then we're going to have these two roots, and they're going to be exact roots. X equals and x equals. So negative 4 plus 7 is the first thing that we are going to figure out, and that is 3. That's a positive 3. And then negative 4 minus 7 is negative 11. So those are the roots that this quadratic passing the x-axis, and that's it. You did this whole thing by completing the square, and those are exact values. Now, I want to do two others that are going to be quick, but one is going to be exact values, and then one is going to be simplest radical form. Okay, so here is the second question, and we're going to solve the quadratic for the exact values of x, and we have a constant over here on the left side, so I'm going to move that constant over to the right side. Using inverse operations, we're going to subtract 3 on both sides. This cancels. We're going to rewrite x squared plus 12x equals -2. Notice there are no constants on the left side now. Now I'm going to list a equals, and a equals 1, and then b equals 12. So now we're going to take b and we're going to divide it by 2. Which is 6, and then we're going to take 6 and we're going to square it, which is 36. We are going to go back to the quadratic and add 36 to both sides. I'm going to rewrite the quadratic, just adding what I have to add on the right side over there. That is 36 plus -2, which is 34. Now I'm going to take the trinomial and factor it into two binomials. And I don't have to look far for the terms x and x, and here it is, 6. So I'm going to put +6 and +6. Nice and easy. When I have that, I have two binomials that are exactly the same, so I'm going to put it in exponential form, x plus 6 squared. And then I'm going to rewrite it up here because I'm running out of space, so x plus 6 squared equals 34. I am going to square root both sides, solving for x. This cancels, and I have x plus 6 equals plus or minus square root of 34. I'm going to minus 6 on both sides. This cancels, and I'm going to get x equals -6 plus or minus square root of 34. And I would leave it like that because those are exact values. Those are the exact values. Now, if I wanted to go ahead, if they said round to the nearest, I don't know, hundredth, then I have to put that into the calculator and then get the decimal equivalent and then basically round it to whatever it is that they need to round it to. All right, and so I put over here, if they wanted it rounded to the nearest hundredth, you would put exactly what this is into the calculator as -6 plus square root of 34. You get -0.17 rounded to the nearest hundredth. And the way you would put the x symbol is x and a squiggly equal sign. It means that it's estimation. And then it's rounded. And then this one would be -6 minus square root of 34, and the same thing, just like this. So just quickly, the next one is simplest radical form. So we're going to just add the same thing. We're going to basically add the constant over to the other. It has to be in simplest radical form, so this is a little bit different than what it was that I showed you before. So we have the constant over to the right side, and we're going to take b, which is -8 in this case, and divide it by 2. That becomes -4. Then you're going to take -4 and you're going to square it, and that becomes 16. You're going to add that 16 to both sides. And I'm going to rewrite it like I always do. And that's 3945. And again, I'm going to put this, I'm going to factor this trinomial into two binomials, not looking very far for the factor. It's -4 and -4 equals 45. Then I'm going to x minus 4, I'm going to put that in exponential form. And I'm going to square root both sides. When I square root both sides, this cancels, and you get x minus 4. I'm going to put this back up here. This is x minus 4 equals plus or minus square root of 45. Now, you could do this at any time, but I'm going to add the 4 to both sides. Just like solving for x, right? We're just basically solving for x. This cancels, and you're going to have x equals 4 plus or minus square root of 45. Now, it says simplest radical form, and so that means that you cannot leave the square root of 45 that way. This is an exact value, but if it says simplest radical form, you have to simplify this radical. So what you do is you're just going to take the x equals 4 plus or minus, and we're going to do this right now. This is a one radical for a perfect square and another radical for a non-perfect square. So what happens is that this square root of 45 has a perfect square that goes directly into it. And you're going to put that into the perfect square radical house. And then you're going to put the non-perfect square into the non-perfect radical house. So what times what equals 45? Now you could just list 45, do 1 times 45, 2 doesn't go in, and then figure out exactly what is the largest perfect square that goes into 45. Now, in my head, it's 9 times 5. 9 times 5 is 45. So that means I'm going to put 9, that is the perfect square, and 5 is the non-perfect square. So what happens is that you have x equals 4 plus or minus, and the square root of 9 comes out as 3 square root of 5. And that is simplest radical form. And they call it simplest radical form because the square root of 5 cannot be, there's no perfect square that goes into 5. So that's it. So 45 had a perfect square that went directly into it, and that's about it. So like if they have, like, say, square root of 50, you know the perfect square, the large perfect square that goes into that is 25. 25 times 2. So you would put the square root of 25 times the square root of 2, and then square root of 25 is 5, radical 2. So that's how you basically will see it. If they ask you for simplest radical form, you have to continue to simplify that radical into a perfect square times a non-perfect square like I did here, and that is your final answer as far as that goes. Those are the three types of questions that they could ask as far as completing the square, and I hope that video helped, and as always, thank you for watching, and I'll see you next time.